This is starting chapter 5, all about solving systems of linear equations. This is 5.1, solving systems of linear equations by graphing, part 1. So a system of linear equations is a set of two or more linear equations in the same variables. So they're both equations that will graph as straight lines, and they have the same variables in there. So these two equations, they both have x's and they both have y's. If I were to graph them, they would form straight lines. We can also have a solution to a system of linear equations, and that would be an ordered pair that is a solution to each of the equation in the system. So if I have a point, which is an ordered pair, and I plug it into both equations, it would be true. It would be a true point for each equation. So we are going to test a few of them and see if the ordered pair is a solution to the system of linear equations. To do that, we are going to plug in the point to those equations and see if we get a true statement in the end. So if I have my equations, x plus y equals 5, and 2x minus 3y equals negative 10, and I have the given point 1, 4, remember ordered pairs are listed as x, comma, y. That's how they always are. We're going to take 1, 4 and plug it into each equation and see if I get something true. So plugging it into equation 1, I would have 1 plus 4 equals 5, and we know that 1 plus 4 is 5, so 5 equals 5. That is true. Then plugging it into equation 2, I have 2 times 1 minus 3 times 4 equals negative 10. 2 times 1 is 2, negative 3 times 4 is negative 12, 2 minus 12 is negative 10. So this is a true statement, and we have 1, 4 is a solution to the system. Another example, if I have y equals negative 2x minus 6 and y equals x plus 4, and I am given the point negative 3, 0. So plugging in that point to equation 1, we get 0 equals negative 2 minus 3, negative 2 times negative 3 minus 6. That is 6 minus 6, so 0 equals 0. We know that's true. Plugging it into equation 2, I have 0 equals negative 3 plus 4. This is where this would not be a solution because negative 3 plus 4 is 1, and 1 does not equal 0. So no, negative 3, 0 is not a solution to the system. Let's try another one. If my equations are 3x minus y equals 15 and y equals negative 2x plus 1, I'm given the point 2, negative 3. I will be plugging this into equation 1, and I see that I will get 9 equals 15. And we know that is not true. So I already know based on this first one that the point is not a solution to the system, but just for good practice, let's plug it into the other one and see. And we will get negative 3 equals negative 3. So it's a solution to one of them, but not both. And so 2, negative 3 is not a solution. Let's try another one. So if I'm given negative 4x plus 2y equals 20, and y equals 3x minus 10, and the given point of 5, 20, plugging those in to equation 1, it is a solution. Plugging that into equation 2, I would get 20 equals 5, and that is not true. So this is not a solution. I have a couple more examples. So for negative 4x plus 2y equals 20 and y equals 3x minus 10, I'm testing the point 20, 15. So this is the same thing that I just did up here, I'm just trying a different point. This satisfies equation 1, and plugging it into equation 2, this is a solution.